Hello everyone, a very good evening to one and all of you. I hope I am audible and visible. Yeah, already it's 10 minutes, so let's start the session. So my name is Pooja Verma and I am a research scholar from IIT Kharagpur and instructor for this course is Professor Shantanu Chattopadhyay, Electrical and Electronics Engineering Department, IIT Kharagpur. This is a week 11 live interactive session on digital circuits. You can use the chat box or ask me interacting. So I hope all of you have gone this week video lectures. So for this week, this is the outline of this week video lecture. First on the architecture of Intel 8085 microprocessor, then the early arithmetic and logic units, registers, the 8085 instructions, the address and databases and timing diagram. Okay, so let's solve some problems which is very similar to your assignment questions. So it may be helpful within your problem solving. Okay. Okay. So this is the first question. So first question is the program counter in a 8085 microprocessor is a 16-bit register because option A it counts 16 bit at a time. There are the 16 address lines. Option C it facilitates the user is storing 16-bit data temporarily, or option B it has to fetch 2 bit to 8-bit data at a time. So which option is correct? So question is the program counter in a 8085 microprocessor is a 16-bit register because it counts 16 bit at a time, or there are 16 address lines. So correct option is option B. There are 16 address lines. Okay, already we know that 8085 microprocessor has a 16 address lines and 8 data lines. So based on that, the program counter is a 16-bit register. So we can say that a program counter so program counter. The answer is indeed a program counter is a special purpose register that stores the address of the next instruction that needs to be executed. Since address bus consists of 16 lines in an 8085 microprocessor, so 16 bits are required to store any address. Okay, so program counter is a special purpose register which stores the address of the next instruction that needs to be executed. To be executed. The 8085 microprocessor processor consists of 16 lines address bus. So that is to 16 bit address. Bit address. Okay. So correct option B. Okay. So moving to the next question. So next question is in Intel 8085A microprocessor, ALE signal is made high to option A. Enable the data bus to be used as a low order address bus. Option B to latch data D0 to D7 from data bus. Option C to disable data bus, or option D to achieve all the functions listed above. Okay. So which one will be the correct option? Okay. So ALE stands for address latch enable. Okay. So it is an active high output signal that indicates the bits on AD7 to AD0 are the address bits. The signal is used to latch the lower order address from the multiplexed bus and generates a separate set of 8 address lines A7 to A0. Okay. So ALE stands for address latch enable. Address latch enable. Okay. It is an active high output signal. It indicates the bits on AD7 to AD0 are the address bits. This signal is used to latch the lower order address from the multiplex bus. Okay, so this signal is used to latch the lower order address from the multiplex bus. Okay, and generates a separate set of 8 address lines. Okay, so option A is the correct answer for this question. Enable the data bus to be used as a lower order address. Okay, so moving to the next question. So next question is in 8085, which of the following modifies the program counter? So option A, only PCHL instruction. Option B, only add instruction. Option C, only JMP and call instructions. And option D is all instructions. So question is in 8085, which of the following modifies the program counter? So which option can be correct? As already we know that the program counter is a 16-bit register that stores address of the next instruction to be executed. Okay, so the processor updates the PC after fetching the instruction. So which options can be correct? So what is the function for PCHL? So it copies. So let's go through the option by option, then we can understand the content of HL in PCS directory. Copies the content of H L register into the PC. The content of H are placed in high order and the content of the L is placed on the lower order bit. Okay. What add instruction will do? It adds. What is the function of adds? Adds the content of register specified register to the accumulator. And option C, JMP and call instruction. Call instructions, what they do? It is a unconditional jump instruction. This one is that changes the PC to transfer the flow of executions, right? JMP and call. Transfer the flow of execution. The flow of execution. That means, for example, JMP is a call instruction or a jump instruction. When call will be executed, then that means the program will be transferred to the other location. In that case, the program counter modified, because program counter what this it program counter will learn it what it is, then it pointed the next address of the next execution, right? So option C will be the correct answer, because in add operation the program counter will not modify in PCHL also. So only jump and call instruction program counter will modify. Okay, option C is the correct answer for this question. Okay, so moving to the next question. So next question is, if CS A15-A14 and A13 is used as a chip select of a 4K RAM in 8085 system, then its memory range will be, what will be the memory range? So can you answer this question? Please try to answer this question. B. Okay, let's see. Okay, so already it is given CS is equal to A15 dash A14 and A13. That means it can be written as 0, 1, 1, right? In place of that, that means these places are fixed, okay, in a 4K RAM in the chip select, and all other locations are can be varied, okay. So let's try to find out the addresses. A15, A14, A13, A12, A11, A10, 9, A8, A7, 6, 5, 4, 3, 2, 1, and 80. So as already we know that these places are fixed, so 0, 1, 1, and all other places can vary from 0, 0, 0 to 1, 1. It can be vary, right? So then 0, 1, 1, these are fixed. Now you can take care 1, 1, 1 because last are 1, 1. The different will be same. So what will be the, if we take a grouping, so what is it? 6, 0, 0, 0 in hexadecimal, right? Can you say that? H. Now next range will be What will be? If we go 4, so it is 7, right? 7 F F F, right? Into H. Okay. So the range will be 60000 to 7 F F. And here it is the 4K RAM. So K already we know that 2 to the power, it is a 2 to the power 2 into 2 to the power 10. 2 to the power 12. So from here it can be vary. So if we write down 6000 to 7FF, so only option B is matching, not 7002. It is 6. Okay. So here for 4K memory, if we write it into a 2, so it can be write from 60000 to 6FFF, then 70002 to 7FFF. Okay. So correct answer is D. Now, moving to the next question. So, next question is the content of a resistor P and accumulator A of 8085 microprocessor are 49H and 3A respectively. The contents of A and the status of a carry flag and sign flag after executing sub B instruction are. So, let's, what will be the content of resistor B? That is 49H. That means in hexadecimal. If we convert it into a decimal, what will be the value? Can you tell me? Please try to convert it and answer in the chat box. Now, what will be the accumulator? The value of accumulator, that is 3A, right? It is also in hexadecimal. Can you convert it into a decimal? Now we have to execute a sub B. That means instruction subtracts the content of register B from the accumulator. Okay, you can solve it like that only, that also, or sub B means subtract the content of register B from accumulator and store the result in the accumulator. That means A minus B, right? Okay. So what is the content of accumulator? A minus B. So it is a 3A, and the content of a resistor B, that is 49H, right? Here we can directly subtract, or we can change it. If you change it into a decimal, then you will get 73 in decimal, and the 3A will be converted into decimal. The value will be 58. Okay. So from here you can also take it 58 minus 73, or you can directly 73 minus 58. Then you will get a minus. So 13 minus 8, that is 5, 1. So minus 15, right? But it is in a decimal. Okay, if you convert it into a hexadecimal, you will get F1. Okay, so from here we can also here A means 10, right? In hexadecimal. Already we know that. That means 10 minus 9 is 1. Now here we cannot convert it, so we need to take a borrow, right? So borrow, it is a hexadecimal, so we have to take 16. In that case, 16 plus 3, 9. Sorry, 19. 19 minus 4, 15. 15 means F. Okay, so in hexadecimal F1, and here you will get, when you convert it and then you will do all those things, so you will get F1 only. Okay, now carry flag will become 1 because we have taken the borrow, because of borrow we have taken, right? And sign bit, I can write sign bit, I can write here, sign bit is also 1. Why? Because the result is negative. Okay, because result is negative. So sign bit set to the 1. Then what is the content of accumulator? That is F1. Carry bit will be 1 and sign bit is also 1. So which option will be correct? Option A will be the correct answer. Okay. Yeah. So have you understand this question? Yeah. Option A will be the correct answer. Okay. So moving to the next question. Okay. So next question is, which block with a microprocessor performs the integer arithmetic and bitwise logical operation? Option A is a arithmetic logic unit. Option B is register file. Option C is a control unit. And option D is a memory block. So as already we know that the arithmetic and logic unit performs the arithmetic operations and bitwise logical operation. So option A is the only correct answer. Okay. So what other options are doing? So register file stores temporary data and instructions, and control unit directs the operation of the processor by managing the execution of the instruction. So it controls the operations by executing. Okay. And memory block also stores data and instruction but does not perform the arithmetic and logical operation. Only ALU, ALU stands for arithmetic logic unit, is responsible for performing arithmetic and logical operations on a data. It can perform operations such as addition, subtraction, and many more functions. Okay, so option A is the correct answer of this question. Okay, so moving to the next question. So in the next question, an 8 kilobyte ROM with an active low chip select input CS is to be used in 8085 microprocessor based system. So the ROM should occupy the range address range 1000H2 to FFFF. The address lines are designated as A15 to A0, where A15 is the most significant bit. One of the following logical expression will generate the correct CS signal for ROM. So which option will be the correct expression to generate a correct CS signal? So address range is given. Here the address range is F000H to FFFH. Okay, and ROM is also 8 kilobyte, so 8 kilobyte, then 2 to the power 3 into 2 to the power 10, that is 2 to the power 30. Okay, so let's see. That is A15 to A0, then address line is designated, and A15 is the NSK. Already we know that. A14, A13, A12, A11, A10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Okay, so the address is 1000 to 2F. So let's see how it will represent. No, it's not. That just yeah, it is 100. So how we can represent 1? So 00001, and it will represent as 1 and all other are 0. So it is a head for this one, right? It can be represented. Now next one is 2, right? So 0010 representation of 2, right? And F, that means all 1. Okay, so it is a address range, right? So here we can see that A15 and A14 both are 0 in both the cases. A15 is equal to A14 is equal to 0 in both the cases. Both the cases. And A13, A12 is 0, 1 or 1, 0. Okay, in case of 100, this one it is a 0, 1, and another case it is a 1, 0. Okay, so that is A15 and A14 is 0, and A13 and A12 should not to be 0, 0 and 1, 1, right? So what will be, what the expression can be made? So I can write it here. So A15 and A14 will be 0, 0. So we can write it in the different way also, but A15 plus A14, right? Plus A13 and A12 is should not be 0, 0 or 0, 1. So 1, 1 represents what is A13, A12, and 0, 0 will represent A13 dash A12 dash, right? So this expression can be made A15 plus A14 plus A13, A12, and because that range should not be there. Okay, so this one is the correct expression is none of expression is matching with this, but I think here it is forward. The A12 dash will be there. So if there is a A12 dash will be there, the correct option is A only. Okay. So the correct expression is A15 plus A14 plus A13 A12 plus A13 dash A12 dash. Okay. Okay. So I hope you understand this question. So moving to the next question. So next question is the clock frequency of an 8085 microprocessor is 5 megahertz. If the time required to execute an instruction is 1.4 microsecond, then the number of T states needed for executing the instruction is. The seventh states correct answer, but how we can solve this question? How can we move forward? Okay, so given 1.4 into 5. Directly you are multiplying, no, but that one, that is not a correct way to solve. Okay, so here it is a given clock frequency, that means f clock is 5 megahertz and time required to execute an instruction is 1.4 microsecond. Okay, so what will be the formula? Time required to execute an instruction and instruction is equal to number of t states needed, number of t states multiplied by t clock. F clock is given, we can find out the t clock, right? So t clock is equal to 1 by f clock, right? So 1 by 5 megahertz, then we will get 0.2 microsecond, right? Here time required to execute an instruction is given, that is 1.4 microsecond. And then number of t states we need to find out. Now multiply by t clock, that is 0.2 microsecond. Microsecond will be cancelled out, and t is equal to 1.4 divided by 0.2, you will get 10, 7. So number of t states will be number of t states is equal to 7. Okay. Now correct answer will be C. C is the correct answer for this question. Okay. Okay. So moving to the next question. Now I hope now you have understand this question. The correct formula is this: time required to execute an instruction, number of t states into a t clock. Okay. Okay. So moving to the next question. So next question is, the following 5 instructions were executed on an 8085 microprocessor, that is MVI-A 25H, MVI-B 91H, ADD-B, then CMA, ANI 68H. The accumulator value immediate after execution of the instruction. What will be the okay? So what is the instruction MVI mean? MVI A means MVI A means move immediate data to register A. Move immediate data to register A. Similarly, M for MVIB is a move immediate data to register data to B. What add means? Add means add register B to the accumulator. Add B to accumulator. CMA, what instruction for CMA means? Complement the content of accumulator, right? Complement the content of accumulator. Now, what does ANI do? ANI, ANI 68. What will be the, yeah, 48 H is the correct answer, but how ANI? What operations we perform? Logically and the content in a accumulator. And the content with accumulator. With accumulator. Right? So let's see what will be the currently the content in register A is 25H and the content of a register B is 91. Now next instruction is add B, means store in A plus B and store in A. Okay. So now add A plus B and store in, now content of the accumulator will be 11 and 6. What we can represent in hexadecimal? B6, right? In hexadecimal. Okay. Now what will be the next operation? CMA, that means complement the content of an accumulator. The current content of the accumulator is, what is, right, 1011 and 0110. If we complement it and they store in the accumulator, the value of the accumulator will be 0 1 0 0 1 0 0 1, right, after CMA. Now next instruction is ANI 68, means and logically and this content 68 with accumulator. Now 68 can be represented as a 68 0 1 1 0 1 0 0 0. So logically and they store the content in the accumulator. So logically and 0 1 1 0 1 0 0 0. So if we add this, that is 0 0 0 1 0 0 1 0. And then final content will be the accumulator is 0 1 0 0. Now final content I am writing here, that is 0 1 0 0 1 0 0 0. What will be the value? This is a 4, this one is a 8 in hexadecimal. 48 H. Yes. So correct answer is P. Option B is the correct answer for this question. Okay. And now I hope you understand this question. So moving to the next question. Okay. The next question is also based on the instructions. So an 8085 assembly language program is given below. Assume that the carry flag is initially unset. That means carry flag is 0, right? The content of an accumulator after the execution of a program is MBI A. First instruction is MBI A. That means in register A the value is 07 stored immediately. Now RLC. RLC stands for rotate left to carry. Rotate left to carry, right? RLC. Rotate left to carry. Rotate accumulator basically. So now what is the content of in register A? That is 0 0 0 0 7, right? So 0 1 1 1. This is the content of an accumulator. Now RLC, that means, and what is the value in a carry flag? That is 0. So rotate left to carry. Okay. So we have to rotate this side but to carry, right? Carry is given as 0. So rotate this side. So 0 0 0 0, 1, 1, 1, 0, right? Because carry it will rotate like this. It will come here and again carry it like this again will be 0 only. Okay. So now the new content in the accumulator is this. Now move V to A. Okay. So that what does means move B to A. Content of accumulator copied to the register B. Right? Content of the accumulator copied to register B. Now what will be the content in B? This one 0 0 0 0 1 1 1 0. Okay, and the accumulator will be same. So now next instruction is RAL. What is RAL? What instruction this it is follow? It is also rotating the accumulator. Rotate accumulator. Okay. Accumulator left but without carry, right? So again rotate accumulator. So the content will be the accumulator will be what will be the content in the accumulator? That is 0 0 0 1 1 1 0 0. The new content in the accumulator will be this one. Okay, right? Now next instruction again RLC with the rotate accumulator left to carry. So now again rotate it. Here I can write it otherwise RLC it is a R A L expression. It is a move B to A. This one is a move. It is a R and C. Okay. Now again the content in the accumulator will be carry is 0. Already we know that. So 0 0 1 1 1 0 0 0. So new content in the accumulator will be this one. Okay. Now again add V. Now content of a accumulator will be added to the register B. So in the register B, it is this one and content in the accumulator is this one. So let's add this A to B and store in the accumulator. A plus B. So A is the 0 0 1 1 1 0 0 0 and in the B it is 0 0 0 0 1 1 1 0, right? So now see 0 1 1 1 1 0 0 0 1 0. The new content in the accumulator will be 0 1 0 0 0 1 1 0 and stored in accumulator. The new content in the accumulator will be this one. Okay. Now again RRC. RRC stands for rotate accumulator right to carry, right? RRC. Rotate accumulator. I am writing ACC. Right to carry. Okay. So now in the carry already we know that the carry is 0. So again we have to move right. That means in this direction, right? So what will be the content? That is 0 0 1 0 0 0 1 1, right? Okay. So now what will be the content, final content in the accumulator? Stored in the accumulator. So it is, what will be the value? It is 2 and it is 3. That means 23H. So final content in the accumulator is this and corresponding hexadecimal value is 23. Okay, so they are asking the content of the accumulator of the execution of this program. So after execution of this program, the content in the accumulator is 23H. That means option C is the correct answer for this question. Okay. Okay. So I hope you understand this question. Can we move to the next question? Okay. Okay. So moving to the next question. Okay. So next question is after the execution of the instruction XRA A, the content of A, carry and zero flags are respectively. So what is the XRA operation? XRA instruction XRA A. What does it mean? Means XOR the content of R with accumulator, where R is any register, that is A, B, C, D, any register or any memory location or any memory location. Okay. So initially already we know that all the content in the accumulator will be 0 0 or any other location also. That means 0 0 0 0 0 0, right? So if we XOR the content with accumulator is also 0 0. If we XOR these two, so again already we know that different bits XOR is 1, otherwise it is 0, right? Is 1. So if we XOR it again, we will get only 0 0 0 0. So content in the accumulator will be 0 0. Now what will be next? Carry flag. What will be the content in the carry flag? Carry flag is also 0, right? Because there is a no carry generated. Now the 0 flag. All the contents in the accumulator is 0, so 0 flag will be set 1. All the content is because of all the content in the accumulator is 0, so 0 flag will be set. Flag is equal to 1. Okay. So what answer will be correct? Which option? That means accumulator is 0 0, carry flag will be 0 and 0 flag will be 1. So option D is the correct answer for this question. Okay. Okay. I hope you understand this question. If you have any doubt, you can ask. Otherwise, we can move to the next question. Okay. So moving to the next question. Okay. Okay. So moving to the next question. Next question is an RRC instruction in 8085 microprocessor instructions that will affect RRC. What RRC? RRC stands for rotate, accumulator, right? Okay. So an RRC instruction in 8085 microprocessor instruction set will affect carry flag. Option A is carry flag will affect, or sign flag will affect, or C. Option C is Z, zero flag will affect, or option D is carry, sign, or Z flag. Three are affected. So let's see. Flag register. What are the values in the flag register? already we know that the different bits in the flag is D7, D6, D5, D4, D3, D2, D1, D0. So MSB is already we know that that's the sign flag. Now next one is a zero flag. Now next is nothing here, and next one auxiliary carry. Okay, and here also now here it is a parity flag. Here it is also nothing. Here AD0 is a carry flag, right? Here is the auxiliary carry. This is zero flag. This is sign flag. Okay. So since D0 is a place in the carry flag, so the value of carry flag will be affected only after the RRC instruction. That means rotate accumulator right. Okay, that means we need to rotate in this direction to carry. So only carry flag will be affected, not other flags will be affected. Okay, so option A is the correct answer for this question. Okay, so moving to the next question. This is the basic one. You can see anywhere. Okay, so moving to the next question. So next question is, what is the difference between move and MVI instruction of an 8085 microprocessor? What would be the difference? So option A is move instruction MOV copies data between two registers, whereas MVI instruction transfer and immediate data into a register. Okay, option B is MVI instructions copies data between two registers, whereas MOV instruction transfers and immediate data into a register. Option C is both move and MVI instructions transfer and immediate data into a register, or option D is both move and MVI instructions copy data between two registers. So as already we know that move instruction used to copy data between two registers or between register and a memory location or a memory location to register. Okay. For example, move A V, right? Move A comma V means copy the content of B to A, and MVI stands for move immediate. That means move immediate is used to immediate data move. Okay, so it is written as MVI A32. That means move immediate data 32 into a accumulator is 32. Okay, so the difference is move operates between the register or memory, and MVI directly transfers the value into a register or a memory. Okay, so option A will be the correct answer. Move instruction copies data between two registers, whereas MVI instruction transfers and immediate data into a register. Okay, okay. So moving to the next question. So next question is, in 8085 edition, which of the following flags are set when addition of MSB is more than 10? So option A is 0, option B is overflow, option C is carry, or option D is auxiliary carry. So already we know that wherever we add two numbers or two instructions or two values, two data, then if carry is generated, if MSB is more than that value, so we know that the carry will be generated, that is the carry or borrow. So carry flag will be set in that case. So option C is the correct answer for this question. Okay. So already we know that in 8085 edition, which of the following flags are set when the addition of MSB is more than 10. Okay. So if it is more than 10, the carry flag will be set. Okay. So option C is the correct answer for this question. Okay. So moving to the next question. So next question is the following instruction indicates which types of addressing mean. So instruction is LDAX. LDAXP. So what does it means? Load accumulator using register pair. Here register pair is B, so register pair P. Okay. LDAX means load accumulator using register pair. Okay. So register pair here it is given, so that means BC will be loaded. Okay, register pair BC is used as a pointer to the memory location from which the data is to be loaded into a accumulator. Okay, since the address of the data is indirectly specified. Okay, so this is a indirect addressing mode. LDAX will come under the indirect addressing mode. So option C is the correct answer for this question. So I can write here register pair here, that means BC, right? So register pair BC is used as a pointer to the memory location from which the data is to be loaded to be loaded into the accumulator. So since the address of the data is indirectly specified, so this is indirect addressing mode. Okay, so option C will be the, so this means this is indirect addressing mode. Okay, okay. So I hope you understand how the data has been accessed and how we can call it a indirect addressing mode. Okay. So moving to the next question. So next question is which of the following will be done in 8085 microprocessor when an instruction LXI H2070H is executed. LXI H2070 H, which means here the hexadecimal. Which of the following will be done in an 8085 microprocessor when instruction LXI H2070H is executed? So option 1 is 70H is loaded in an HL register and 20H is loaded in L register. Option 2 is content of the memory 2070 is loaded in H register, or option 3 20H is loaded to H register and 70H is loaded in L register, or option 4 is 2070 is loaded in H register. Okay, so which operation it will do? So LXIH instruction directly load the higher bit to a 16-bit operand, that is 2070 into H register, and lower bytes into a L register. Okay, I can write it here so that others can understand. So LXIH instruction directly load the higher byte of 16-bit operand, that is 2070H into H register and lower byte into L register, right? So 20 is the higher bit, so it will be loaded into H, and 70 will be a lower, so it will be loaded into L, right? So into H it is a 20 H, and into L it is a 70 H will be loaded. Okay, so 20H is loaded into H register and 70H will be loaded into a L register. Okay, so option 3 will be the correct answer for this question. Okay, so I hope you understand this question. So moving to the next question. So now next question, what is the vectored address of RST5? Option A is a 0010, option B is 0032, option C is 0028, option D is 0030. What will be the vector address of RST 0.5? RST5. So vectored address of any RST can be calculated. The vector address of RST and is calculated by n into 8, right? So for RST5, it will be n is 5, 5 into 8, that means 40, but it is in a decimal. Okay, so if we want to convert it in a hexadecimal, what we need to do? We need to just divide, right? So that means 28 hex in hexadecimal. Okay, so if we can write it like this, 2028H. So the vector address for RST5 is 0028. So option C is the correct answer for this question. Okay. Okay. So I hope you understand this question. So moving to the next question. Can we move? Have you understand this question? Okay. Thank you, Abhishek, for confirming. Moving to the next question. So next question is, suppose so register A and B contains a 50H and 40H respectively. After instruction move A, comma B, what will be the content of register A and B? So can you answer in the chat box? This one is a very easy one. So here register A, in the register A the content is 50H, and register B the content is 40H. So if we perform an operation, Yeah, option A is the correct one. Yeah, right, Abhijit. So you move A comma B, what it will do? Move the content of B, move the content of B to A. Means the content in B it is moved to the A. So in A now it is a 40H, right? The content B to A. Yeah, B to A. So now in accumulator it is a 40H. So in both now B already have a 40 and in accumulator it is also a 40. Okay, so after moving, so in both that is A and B both the content is 40H after this operation. So option A is the correct answer for this question. Okay, so okay, I hope you understand this. So moving to the next question. Okay. So next question is in a microprocessor, the address of the next instruction to next executed is sorted in stack pointer. Option 2 is address latch, option 3 is program counter, and option 4 is general purpose register. So already we know that program counter acts as a pointer to the next instruction to be executed. And it already we know that 16 the address of the memory location of the next instruction. So program counter points to the next instruction to be executed. Okay, so program counter is the correct answer. And what will stack pointer do? Stack pointer in 8085 microprocessor is also a 16-bit register that it stores the address of the top of the stack memory. It will store the address at the top of the stack memory. General purpose registers already we know that that is BC, DE, HL are the general purpose register. It contains an 8-bit. It will store the 8-bit data. And address latches are the addressing that is AD0 to AD7, right? That are the address lines. So option 3 will be the correct answer for this question. Okay. So moving to the next question. So yeah, next question is the total number of memory access involved when an 8085 processor executes an instruction LDA 2003H. The total number of memory accesses involved when an 8085 processor executes an instruction LDA 2003. Okay, LDA means what this perform? That is load the accumulator with the content, and content is location 2003. Okay, so it includes how many operations or how many machine cycles? It includes 4 machine cycles. First one overview of code fetch. Now 2 is read operation. That means 28. Number G also again read operation 03. Number fourth one read the content at. Read the content of 2003H. Okay, so total 4 machine cycles are required to execute instruction LDA 2003. Option 4 is the correct answer for this question. Okay. Okay. So these are the instruction based questions. So you can read about all these instructions, what their operation, what they will do. Okay. So then you can able to understand. Okay. So moving to the next question. Now, next question is to multiply a number by 8 in 8085 microprocessor, we had to use RAL instruction. How many times we can use the RAL instruction? Number 1 is once, option 2 is twice, option 3 is thrice, option 4 is 4 times. To multiply a number by a 8, if we want to multiply a number by 8, so how many times this RAL observation instruction will be need to perform? So RAL, what RAL instruction will rotate accumulator, rotate, this is rotate accumulator left to carry. Okay, so already we know that it is 8 bit D7, D6, D5, D4, D3, D2, D1, D0. Okay, so if we want to rotate left, so we have to move in this direction. These bits will move this direction, right? And this will again to carry, so carry will be there, and that carry will be stored with there. So let's see, for example, in this we have stored 1, 1, right? So if we rotate it, so multiply by a number, if we multiply 1 into 8, so 8 will be there, right? Okay, so let's see if how many times it will rotate, so we will get 8, 1 into 8. So they said to multiply a number by 8, 8085 microprocessor we have to use RAL. So how many times RAL instruction we have to use? So let's see, we have taken for simplicity to understand you. I have taken the content in the accumulator is 1 and then multiplied by 8. So 8 will be stored. So we need to find out through this instruction RAL 8. So just rotate to carry. So if we rotate once, first times I am rotating and writing here 0, 0, 0, 1, 0, right? First time. So we have got 2, right? Here 2. Here it is a 1. So again we have to rotate second time. Second 0, 0, 0, 1, 0, 0. So what is the value? It is 4, right? Second time. So now again rotate third time. So 0, 0, 0, 0, 1, 0, 0, 0. So the value in the accumulator is 8. So how many times we need to rotate? 3 times. That means to get a number that is multiplied by an 8, we have to multiply by thrice. Okay. So answer 3 is the correct answer. We have to rotate it thrice. RAL instruction we need to rotate thrice to multiply a number by a 8. Any number it can be. You will get multiplied by 8 that number. You can check it. Okay. Okay. So moving to the next question. I hope you understand this question. Have you understand this question? How we are getting? I hope you understand this question. Okay. Okay. So moving to the next question. Okay. So next question is in 8085 microprocessor, assume that The stack pointer is pointing to a memory location 2000H and register D contains value 1050H. After the execution of instruction push D, the stack pointer would be pointing at which location it will be pointing. So okay, given that stack pointer, yeah, correct object one effort E. But how we can solve? We will solve this question from solving here. Okay. So given that stack pointer pointing at the memory location, stack pointer pointing the memory location 2000 H. It is given, and that means the memory location at the top of the stack. That means this one is a stack. It is pointing at 2000. Okay. After the execution of push D, a new element is inserted at the top of the stack. Okay. Push D. Okay. So in DE register, it is containing 1050. Already here it is written. If we perform the push D operation, a new element, a data, is inserted at the top of the stack. Okay, data is 1050H. This push D instruction pushes the content of a D register pair onto the stack. Okay, so now it will be the SD will be when we will perform D, so it will be the D contains D contains 10, E will contain 50. Already we know that if we store that, so it will be the decremented by a 2 location. Okay, let's see. If we perform push D operation, push D operation, stack pointer will decrement. Okay, by 1. So if we perform 1 push DE, so at a lower it will be, so at it will be 1 1 F F. Okay, and again for D it will again decrement by 1 again 1 F F E. Okay, and for D is stored at this location and E by 1 at this location. Okay, so value will be the for 1 F F E will be, because we are performing push D operation, it will decrement at the 2 positions. Okay, so it will be here 1 E, sorry, 1 F F F 1 F F E will be stored D. Value of D is 10, here 50. Okay, okay. So moving to the next question. Okay, so next question is, in 8085 microprocessor, assume the accumulator contains A4 AA accumulator contains accumulator have a value A A H and CY is equal to 0 how many times the instruction RAL must be executed so that accumulator reads A9, and what will be the carry bit reading at that instant. Okay, so RAL stands for rotate accumulator left to carry. RAL instruction. Okay, rotate accumulator left to carry. So what is the value in the accumulator? It is AA, that means 10, 10, 10, 10, and carry is 0. See why it is. So rotate accumulator left, this means rotate in this side, right? Through carry. So let's rotate it, and we have to read the A9. Okay, that means 10, 10, 1001. The value of the accumulator will be this one. So how many times it will rotate? So let's see. So I'm writing here first rotate first time. Okay. So this will be 0, 1, 0, 1, 0, 1, 0, 0. Okay. Again, carry at the carry it is value 1 because that will store it here. Now what will be value? It is 5, it is 4. No, it's not. Value is accumulator is 54H. So it is not matching to A9. Now move to the second time. So second time it is 1, 0, 1, 0, 1, 0, 0, 1. And in the carry it will be this value will be moved to the carry, and this will be here. So what is the current value? It is a 1010, that means A, and it is a 8, 9. So A9 H, and carry is 0. Okay, so we have to move for A9, we have to move RAL two times, and carry will be the 0. We have to move 2 times. And we perform RAL 2 times to get A9H in accumulator. Okay, so we have to perform 2 times. Okay, okay, so I hope you understand this question. So moving to the next question. Have you understand? Okay, so I hope you understand. Moving to the next question. Okay, so next question is, how many key states are required to execute STA 1, 2, 3, 4 instruction? STA 1, 2, 3, 4 instruction. How many key states are required? Okay, so to perform STA, so STA stands for store from a register to memory location. Okay, store from a memory location. So it is a 3 byte instruction, for 1 byte for this and 1 byte for this, 1 byte for this. So it is a 3 byte instruction. So to perform the 3 byte instruction, what are the machine cycles are required? So for upcode, fetch and execute, code, fetch and execute, we need a 4 T states. Okay. Now for first byte address fetch, first byte address fetch require 3 T states, and the second byte address fetch is also required. 3 is the states. Okay. Now write to for writing a memory also 3 T states are required. Total how many T states are required? Total just count it 4, 3, 7, 7, 3, 10 to 13. Total 13 T states are required. So total 13 T states are required to execute STA 1, 2, 3, 4. Okay. So option 4 is the correct answer for this question. Okay. So these are the, it is a 3 byte instruction. So already told 1 byte for this, 1 byte for this, 1 byte for this, and for 3 that byte, how many T states are required? So for upcode fetch and execute, it is a 4 T states. For first byte instruction, address fetch, it is 3 T states are required, and for 2 second byte address fetch, it is also 3 byte required, and for writing to the memory, also 3 T states are required. If you add these, so you will get 13. Okay. The total 13 T states are required to execute STA 1, 2, 3, 4 instruction. Okay. That means so option 4 is the correct answer for this question. Okay. So I hope you understand this question. So can we move to the next question? Okay. Okay. Abhishek, moving to the next question. So now next question is, in an 8085 microprocessor, the instruction CMPB has been executed while the contents of the accumulator is less than that of the register P. The content of the accumulator is less than that of register B. As a result, carry flag, zero flag will be respectively. So they are saying that the executed that CMPB has been executed. The content CMPB what will do that? That means compare register or memory with accumulator. Okay. So they are saying that executed that has been executed while the content of the accumulator, that means content of the accumulator, they are saying that it's less than to the register B. After executing this instruction, the content of the accumulator is less than the register B. As a result, carry flag or zero flag will be, what will be the carry flag and zero flag? So it is given okay. So if A is less than register, any register or memory location, sorry, it is not register. So carry flag will be set to 1. Okay. And zero flag will be 0 only. Okay. Because the content of the accumulator is less than the register B. So there will be the carry will be generated if content of the accumulator is, and zero flag will be set up because all the contents are not zero. So zero flag will be set to the reset only. Okay. So option 2 is the correct answer for this question. Okay. So here, if content of the accumulator is less than register B, so it will be this. If the content of A is equal to register, So what will be the or memory? So carry flag will be again 1 because it is 1, and 0 flag will be the 0 only. And if A is greater than register or memory, so carry and 0 flag all both are 0. Okay, but here the it is given accumulator is less than register B, so it will be the carry flag will be set to 1 and 0 flag will be 0. So that's why option B is the correct answer for this question. Okay. Okay. So I hope you understand this question. It is a theoretical one. So you can take any number and you can check whether if the accumulator is less than register A. Take any value to accumulator A and take less value in the register B and compare these two. Then you will get a carry will be generated, and 0 flag means all the value in the accumulator will be 0. Then if all the value in accumulator is 0, then it will set to the 1, otherwise it will be the 0. Okay. So you can take any number and check it. Okay. Okay. So I hope you understand this question. This one is the last question for this week. So, okay. So questions are ended. If you have any doubt, you can ask. Otherwise, we can close the session. Okay. Okay. So thank you everyone. Thank you for joining. If you have any doubt, you can ask. Otherwise, we can close the session. Okay. If you don't have any doubt. Okay. Okay. So nobody else has been attended this class. So okay. I hope I have find it clearly so they can understand. Okay. So, okay. Thank you everyone. Thank you for joining this session. So you can now leave if you don't have any doubt. Okay. Okay. Thank you. Thank you everyone. Thank you for joining.